Okay guys, today we're going to go over 5.2 defining slope. I know that you had homework last night. We're not checking it today, so lucky you if you didn't have it ready for today. You got one more day. Make sure that it is ready for tomorrow because I will be checking it then and then we will be going over it. So for now, make sure you have your notes out. 5.2 defining slope. The two things we're going to be doing in this lesson is calculating the slope of a line by using the rise and the run, and calculating the slope of a line from the ratio of the differences of the x and y coordinates. And we're also going to do a little bit of graphing then. So at any point during this video, if you need to pause it to write things down, go ahead and do that. I'm not going to do the wait time because you can pause it and do that yourselves. So I'm going to keep going. If you need to pause to write this stuff down, pause it and then pick up where you need to. Also, if you need to go back and listen to something again, then you have the ability to do that on the video. That's the nice part about the video. So use it wisely, okay? If you happen to check out for a minute and didn't hear what I said on the last two slides, then back it up. Go back and listen to it. That way you get it. So moving forward, there are some glossary terms. Negative slope. The graph will go down when following it from left to right. Okay, there's stuff in red. It's in a different color that usually means it's important. So if I have a negative slope, let me find my, oh, is that not going to come up? Oh, okay. Oh, there it is. All right. So if I have a negative slope line, that's going down from left to right. You need an example, that's what we're talking about there. A positive slope, do that one in green, goes up when following it left to right. Goes up, goes down. That's the difference between your positive and negative slopes. Okay, then we have rise and we have run. Remember, rise is the y's. That's the easy way to remember it. Okay, the rise is the difference in the y coordinates of 2 points on the line. It's up and down. Y measures up and down. That's your rise. Run is the difference of the x coordinates, left and right. And again, you might want to pause here if you need time to write this down. I'm going to keep going forward. Few more glossary terms. Slope. It's a measure of the steepness of a line. And we did talk about this before the other day when we were talking about lines of best fit. Okay, it is represented by the variable m. Make sure that you remember this. Slope is represented by m. Okay, that is important for you to know. Then a horizontal line. Again, things in different colors here, so that's important. The slope of a horizontal line is 0. Okay, and the equation when we get to that will just be y equals a number, and I'll get to why that is later. But a horizontal slope, or sorry, a horizontal line is flat. If you are walking on flat ground, there is 0 slope. Doesn't go up, doesn't go down, the slope is 0. On the other end of it, a vertical line has a slope that is undefined. What we mean by that, vertical is straight up and down. If this were a ski slope, okay, and you went in your little, that was not what I wanted to do. Uh-oh. Okay, and we're back. I think I fixed it. So if you were at a ski slope and you went up in the chair in the left, got all the way to the top of this hill, now you're standing here with your skis. What is going on here? Hold on a second. Okay, that's a pen. I don't understand. Okay. So if you're up here on your skis, little person, and it is a vertical drop straight down. That is so steep, it is undefined. Okay, you're looking straight down and you can't put a number on it. It is so steep, it is the steepest it can be, straight up and down. It is undefined. We cannot put a number on it. That's what that means. So a horizontal line has a slope of 0, it is flat. A vertical line has a slope that is undefined. So a geometric interpretation of slope. Slope measures the steepness of a line and is given by the formula slope equals rise over run. Okay, that should be familiar. That should not be something that sounds brand new to you. The visual representation of it is this, and all this is doing is showing you that the rise is the distance up and down between 2 points, and the run is the distance left and right between them. When we find that, we take that rise number and put it over top of the run number. That is our slope. That is the only thing that this slide is telling you. So now we come to our formula. When we're given the coordinates of 2 points, how can we find slope? Well, one way is by graphing it, and another is by using this formula. So if we're given 2 points, remember every point has an x and a y, we can use this formula, m equals y2 minus y1 over x2 minus x1. And again, here's a picture that represents that. We're going to go ahead and do an example of this. So if this isn't making sense yet, that's okay, but you need to make sure that you have this formula. So first, we're going to find the slope of a line by using the rise and run. I'm going to tell you the rise and I'm going to tell you the run, and it's going to seem almost too easy. The rise is 15, the run is 5. If slope is the same thing as m, okay, and that's the same thing as your rise over run, then my slope, we're going to use m from now on, m equals rise over run. Rise is 15, run is 5, and then I simplify. So m equals 3. The slope of a line that has a rise of 15 and a run of 5 is 3. That simple. If I'm giving you the rise and run, put the rise over the run and simplify. Now we're going to find the slope of a line when we're given 2 points. So there's that formula we're going to have to come back to. So first it says a line contains the points, and this A and B are just the names of the points. Sometimes they'll have letters there and sometimes they won't. That doesn't really matter. It's just telling us there are 2 different points. So we have point A, which is at -3, 4, and point B, which is at 2, 8. We need to find the slope. Well, in order to do that, the first thing we need is that formula. Okay, our formula says y2 minus y1 over x2 minus x1. I have all the work here, but to show you where that came from, every point, like I said before, has an x and a y. This point has an x and a y. This point has an x and a y. So I'm going to label them that way. This is my first point. So I'm going to put 1s on those. That's my first x and my first y. This is my second point. So I'm putting 2s on these. My second x, my second y. Once I have these things labeled, I'm going to go ahead and put them in the formula. Now I want to show you something that's important about this formula. Everything that I put in black is part of the formula. Everything now that I am writing in red is what needs to be replaced in the formula. And the reason I'm doing this is because when you substitute in negatives, this minus is from the formula. The negative we're substituting in is part of that y1. And you'll see that we're going to go through. So if I'm using the same example, everything that's in black, I know needs to be there. So I'm going to do that right away. Then I'm going to go ahead and start replacing. Well, my y2 goes here. My y2 tells me I marked it is 8. My y1 goes in this spot. Y1 we said is 4. Down in the bottom, my x2 is going to go down here. My x2, if I look up here, my x2 is 2. And over here, my y1, if I look up here, is, oh, okay. I'm sorry, guys. Let me erase that out of there. That was my mistake. That should have been an x1. Which is why that didn't make sense. My x1 is negative 3. So negative 3. And you could put it in parentheses like they did, or you can write it there. Just make sure you have the minus that's from the formula and the negative for your x1. Once you have that, you can go ahead and work your way across. 8 minus 4 is 4. 2 minus negative 3 minus negative turns to a positive. 2 plus 3 is 5. So m equals 4/5. Your slope has a rise of 4 and a run of 5. So now we're going to find the slopes when we're looking at a graph. That was how to find it from a point. Now we're going to look at graphs. So this graph on the left, they gave us 2 points, so I can use those. Or I can look at any points that go through the grid. So I could use this point, and I could use that point, or I can use the 2 they gave me. As long as I am reducing, as long as I am simplifying, I will get the same answer. So let's first use the red one, just to prove to you we'll get the same answer. What I need to do is count my rise and my run. Well, that would be my rise. I'm going to go back and count that then. And from here to here would be my run. So rise, I'm going down to get to this other dot. So I'm going down 1, 2, 3, 4, 5. I went down, so it's negative 5. My run, so now I'm here. To get from here over to that second dot, I'm going right. 1, 2, 3, 4, 5. I went right, so it's a positive 5. So if I do, my slope is rise over run, negative 5 over 5, my rise, my run, and I simplify that. Negative 5 divided by 5 is negative 1. My slope of that line is negative 1. And it should be negative because remember we discussed on that first page, a negative slope goes down left to right. So you can double check yourself like that. Now, if you would have picked these 2 other dots, then I'm going from here to here. So if I take this dot, I'm going, which is my run, because I'm going right 1. And then to get from there down, I'm going down 1. That's my rise. Down 1 is negative 1. So if I do my rise, negative 1, over my run, 1, and simplify, I still get the same answer. You just always need to make sure that you are simplifying. Now, I could have gone this other direction. I could have gone down 1, right 1. I still would have gotten the same thing. I could have even started at this dot and gone up, which would be positive 1, and left, which would be negative 1, still gives me negative 1. So down and left are negatives, up and right are positives. Or you can just count the numbers and look at your line. If it's going down, the whole thing is negative. If it's going up, the whole thing is positive. Okay, let's take a look at the second graph. The second graph has 2 dots for us. If I look up that line, there's no other place where that line crosses over a nice corner of the grid. we have to pick dots that are in the middle of a grid. I cannot pick this dot because I would have to estimate that point. Then I'm not counting by lines. That is not okay. I cannot pick that. So the only two we can use on this graph are the two given to us because there's no other ones that actually go through set points. So if we take a look, if I want to count, and this one I'll show you, I'll start bottom going up. If I want to do my rise, I go up 1, 2, 3, 4. So my rise is up 4 is positive 4. And then I'm going to go to the right. That's going to be my run. 1, 2, 3. So if I put my rise over my run, I get 4/3. And that doesn't simplify. I do not want to change it to a mixed number. Leave it improper, 4/3. And I want to double check. I got a positive slope. My line is going up from left to right, and it should be positive. So that checks out. So now that we did that, I want you guys to open your textbooks to page 231, and I want you to try numbers 6 through 10. Pause the video, go through, and try 6, 7, 8, 9, and 10. When you are finished, then press play on the video, and we'll go through them. Okay, so hopefully you did 6, 7, 8, 9, and 10. Now we're going to discuss those and see how you did. So number 6 had a graph that looks similar to this. And it goes through this point, and if you look in your book, that's between these two other boxes. They have a 70 here, and they have a 50 here. So the thing in between them is going to be a 60. So I know this point goes right there, and I know that each of these blocks are counting by tens. Over on to the right, it goes through this point at 70. And if I look across the bottom, each of these dashes are also counting by tens. Okay, they skip the one in the middle, but it goes 10, 20, 30, 40, 50, 60, 70. So I can use these 2 points and count my rise and my run. When you do that and you simplify, we would have to go down 60. So my rise is negative 60. And we go right, my run is positive 70. So rise over run, my slope would be negative 60 over 70. And if I simplify that, that's negative 6 over 7. So my slope, m equals negative 6/7. And if I double check myself, negative slope means that line should be going down, and it is. Again, pause at any point if you need to make corrections on your paper. So number 7 has a line that looks like this. They didn't give us any set point. So I can see that, that's a point. And about here is a point. So I can create my own points, again, as long as they are meeting at that grid. There are other points you could pick there. You could pick 4, 2, -2, -1, and -4, -2. Any of those points you could choose, just make sure that you're simplified. So if I want to find my slope, my rise is going up 1, rise is 1, my run goes 1, 2 spaces. So my run is 2. I went up positive, oops, I don't know why I write an R, 2. I went up 1, positive, right 2, positive. So my rise over my run is 1 over 2. That doesn't simplify. Positive means my line should be going up to the right, and it is. So the slope is positive 1/2. Okay, number 8 said find the slope of a line containing the points -1, 7 and 8, -3. They're giving us 2 points. This is where we need to use that formula, n equals y2 minus y1 over x2 minus x1. So that means I'm going to be using this formula, and everything that's in the black is from the formula. I need to label my other pieces and plug them in. So every point has an x and a y. So I'm going to label both my points x, y. This is my first point, so they're getting 1s. This is my second point, they're getting 2s. Now that I have things labeled, y2 is the first number I'm looking for. My y2 is the -3. Then I need y1 to go in this spot. So y1 is 7. Then down here, I'm looking for my x2. My x2 is 8. And then finally in this last open spot is my x1, which is -1. So again, that minus is from the formula. The -1 is part of my x1. I can't make as though they're the same thing. So then when we go ahead and solve, -3 minus 7 is -10. 8 minus -1, that turns to positive, is 8 plus 1 is 9. So we get the slope, because that does not simplify, and remember, do not change it to a mixed number. Keep it improper. Slope is -10/9. Number 9 said draw the line that has a slope of 4/3 and contains the point -2, -1. So you should use graph paper for these. Graph paper is under the notebook paper on the counter, and a ruler to draw your line. So I'm going to freehand this, but later when we get to more graphing, then I expect you to use that. So the first thing I need to do, the point. Think about it as a starting point. I have to start with the point first. I cannot start with the slope first. I have to know where I'm going from. So I first graph the point -2, -1. And then my slope is 4/3. Well, remember, 4 is my rise, 3 is my run. +4 means I go from my starting point, which is why we had to have that there first. I go from my starting point up 4. So I'm counting up 1, 2, 3, 4. Oh, and I already made a mistake, so catch that. I was not supposed to put that dot there. I have to do my rise and run before I can start graphing a point. So I go up 1, 2, 3, 4, and then I need to run positive, so right, 3. 1, 2, 3. I need to do this another time because I want at least 3 points in a row before I can put my ruler on to make sure that I'm doing things right. So I can either go up 4 again and write 3, or the reverse directions would also hold true. Down 4, left 3, because negative, negative makes a positive. So why don't I do that? 1, 2, 3, 4. 1, 2, 3. So if I go down 1, 2, 3, 4, left 1, 2, 3, I will be about here. If you're using graph paper, these will line up. Then you put your ruler on, draw your line through your points, extend it past those dots, and put your arrows on the ends. And then number 10 said plot the points and draw the line that contains them. Describe the line and what is the slope. So if I do my x, y axis, if I graph -3, 3, and I graph 6, 3, and I draw a line, it says describe the line. Well, that is a horizontal line And when they say, what is the slope? Well, we decided earlier, every horizontal line, it is flat, has a 0 slope. So m equals 0. And then B, if I graph those 2 points, 4, 7, and 4, 3, and I draw a line. Well, now, if I describe that, that is a vertical line. And the slope of a vertical line, m equals undefined. There is no shortcut to this, guys. You need to write the word undefined. Remember, that is that ski slope that is so steep we cannot put a number on it. It is undefined. Okay, so now I want you to do some practice. Here you definitely need to get graph paper and rulers. And remember, rulers are supposed to be used on paper with a pencil. They are not divey boards, swords, lightsabers, or anything that you guys can think of. Okay, they're supposed to be used properly. So graph paper is on the counter underneath the lined paper. So you can help yourself to that. I want you to turn to page 232 and do numbers 36 through 43. Pause the video, do them, and then start the video up and see how you did. If you need help, go ahead and listen to the first one, walk through 36, and then you should be able to go ahead and do the others. So pause now, see what you can do with 36 and 43, and then come back and see how you did. Okay, so hopefully you did 36 through 43, or you're just taking 36 as an example to go ahead and do the others and then check. So number 36 gave us a point of 5, 4, and told us the slope is 2/3. So top number's your rise, bottom number's your run. Remember, we always have to start with the starting point. So I need to start by graphing the point 5, 4, so going to 5 up to 4, and then my rise and my run. Well, the rise is positive, so I can go up 2. The run is positive, so I can go right 3, put my dot. And I could do this again, but I'm going to end up off my graph paper. So as long as I reverse both directions, instead of going up and right, if I go down and left, that will still be a point on the line. So I'm going to go down 2 and left 3 and put a dot. If you are more comfortable, you can keep doing this and putting more dots until you have enough. My bare minimum is 3 though. You must have at least 3 points before you can draw your line. So now you can put your ruler on and you can draw your line. And now I'm not using a ruler on my computer screen, so mine's a little shaky, but line it up nice, put your line on, extend it past, put your arrows on the ends. And you just graph that line. Now, something that I want to bring up before you get too far. Notice when you draw your X and your Y axis, they must be on the grid lines. They're not floating in the middle of a box. So your X axis has to be on a blue grid line. Your Y axis has to be on a blue grid line on your graph paper. Also, we number the lines, not the spaces. This first line is 1. Second line is 2. When I'm going down, first line is -1. I know it can get cramped in here. So if you need to skip writing the -1, that's fine, but then no, this second line is a -2. You cannot just skip because there's no space and then start -1 down here. Your whole graph will be off. Every first number needs to start at that first line outside the origin. Okay, so if you just needed to be walked through that first one, go ahead and pause, try the rest of them. If not, we're going to keep moving through, see how you do on the others. So number 37 gave us the point -5, -3, and a slope of 3/4. Again, I'm going to label my rise and my run. So I need to start with my starting point. So -5, left 5, -3, down 3, Remember, it's always x first, then y. And from my starting point, I'm going to use my rise and run to get 2 more points on this line. So I'm going to rise 3, 1, 2, 3, run positive 4, 1, 2, 3, 4, put a dot. And I have plenty of space, so I'm going to keep going this direction. Up 1, 2, 3, right 1, 2, 3, 4. So if you're doing this correctly, when you put that ruler on, they should line up. If you put the ruler on and they don't line up exactly on the same line, then something went wrong. You need to go back and check your counting again. Once I have at least 3 dots, I'm going to put the ruler on, draw my line, extend it past my dots because that line goes on forever, and draw arrows on the ends. Good, let's try number 38. Number 38, we get negative 3, 4 as our point, and we have a slope of negative 1/2. So I start with my starting point, negative 3, 4. I'm putting my starting point. And from there, I'm going to use my slope, my rise, my run. My rise is negative 1, which means I go down 1. My run is positive 2, so I go right 2. That negative in the book is written in the middle of the fraction. My suggestion is that you always include it with the top number, and then your run will always be to the right. Then you don't have to worry about it. What you don't want to do is say that the 1 is negative and the 2 is negative, because that is something different. Negative divided by negative becomes positive. That's not the case. We have a negative slope, so only one of those numbers gets to use the negative. So if I'm using it for my rise to go down, then my run has to be positive. Then I'm going to do the same thing again from this point. Down 1, right 2. I can keep going if I want, but remember that bare minimum amount of points is 3. So once I have that, I can put my ruler on, draw my line, extend it past, put arrows on the ends. If you're unsure of whether or not you went the right direction, double check your line. My slope was supposed to be negative, so my line should be going down. If it's going up, then I probably doubled that negative. Okay, number 39. So 39 has the point 0, 0, and the slope of positive 1/2. So my point 0, 0 is right in the middle. That's at our origin. And then I go up 1, right 2, up 1, right 2. Again, I can keep going for more points. Bare minimum of 3, draw my line, send it past, and put the arrows on the ends. Now you guys are using rulers, so I expect you to be a little more accurate there than I was and actually go through. The more points that you put on your graph, the more accurate your line is going to be. Okay, number 40. Number 40, we have negative 1, negative 5, and a slope of 0, which should tell you something. Slope of 0, we said the only line that has that is a horizontal line. You need to recognize that. So I can graph my point, negative 1, negative 5. And then I know this is a horizontal line. So I'm drawing a horizontal line through that point. That's my line. And what this is saying is it's 0 over something. We don't know what. The top number has to be 0, which means we're not moving up or down, right? We're staying there. That is a horizontal line. So number 41, you should now have an idea where we're going with that. That slope they're saying is undefined. Well, the only line we know that has an undefined slope is a vertical line. So we have the point 3, negative 4. I'm going to plot that, and I know it's going to be a vertical line. So I can draw this somewhat straight. Our vertical line, through the point 3, -4. The reason, guys, that this is undefined, if I have any number divided by 0, because what this is saying is our run is 0. We're not moving left, we're not moving right. We're staying right in line with that. No left movement, no right movement. Take for a minute your calculator and pick any number. So if I have 5 and divide it by 0. If you try and do that in the calculator, 5 divided by 0, it is going to give you an error because we cannot do that. That is why it's undefined. So if you're ever doing the y2 minus y1 over x2 minus x1, and you put it in the calculator and you get an error, you know it's a vertical line because that slope is undefined. Okay, 2 more. Number 42, we have the point 3,1 and a slope of -2. So we're going to start at our starting point, 3,1, and our slope is -2. Well, we only see one number there. That means I need to make it a fraction. The way I make a whole number a fraction is by putting it over 1. -2 divided by 1 is still -2. I'm not changing it, I'm just looking at what's below it. Now if I do my fraction, I can see my rise and my run. -2, I need to go down 2 and run 1. Down 2, run 1. Then I can graph it. And the way you could check this, if you forgot to do this fraction and you thought you were only going down 2 and putting a dot and down 2, putting a dot, you would end up with a vertical line, which doesn't make sense because that has an undefined slope, not a slope of -2. So that should have told you that something wasn't right. You have a whole number, put it over 1 because dividing by 1 doesn't change it, and then you'll see your run. And finally, number 43, we have the point -1, -2, and a slope of -3. So we're going to graph our point, -1, -2. And here again, my slope is a whole number. I need to see the run. So I'm going to divide it by 1 because -3 divided by 1 is still -3. But that allows me to see my run. So here's my rise. Here's my run. I'm going to go down 3, right 1, down 3, right 1. Draw my line and put arrows on the ends. Okay, guys, so that's what you needed to do. The next thing that's going to come up is your homework. So if there is time left, then go ahead and get started with that. If you're going to run out of time, take a look at the problems you need to do and see if you need to grab any graph paper or if you want to practice any of the graphing stuff, grab some extra graph paper if you want to. And try the best that you can on the homework, and we will discuss that tomorrow. And remember that domain and range worksheet that is also due tomorrow. So if you didn't have it done for today, get that done. I will be checking both and reviewing both tomorrow. Okay, guys, have a nice day.